Hey everyone, in this video we're going to look at a quick and easy way to start memorizing the figures that will help you understand glycolysis. So recall that glycolysis is 10 steps, individual steps with 10 different compounds involved. And what I've drawn is I've drawn out sort of a shorthand version of glycolysis where I've sort of abbreviated each of these with much shorter names. So GLU would be glucose, G6P is glucose 6-phosphate, F6P is fructose 6-phosphate, F16BP, fructose 1,6-bisphosphate, DHAP stands for dihydroxyacetone phosphate, G3P, glyceraldehyde 3-phosphate, BPG or bisphosphoglycerate, 3PG is 3-phosphoglycerate, 2PG is 2-phosphoglycerate, PEP, phosphoenol pyruvate, and then finally pyruvate. One thing I want to do in the short version is put in the important enzymes and also where ATP is either made or used, and just point out a couple things that if you could sort of memorize this short little mnemonic, it'll definitely help you understand glycolysis better. So first off, let's put the fact that ATP is utilized here in this first step. So ADP is created, and the enzyme that does that is hexokinase. Yeah, that's the first enzyme in the pathway. And we won't list out all of these, but there are a couple that you really should know. Okay? The next place that ATP is utilized is in the third step. Okay, and this step, the conversion of fructose 6-phosphate to fructose 1,6-bisphosphate, you may recall, is the so-called committed step of glycolysis, and it's catalyzed by PFK. Phosphofructokinase. Okay, continuing on, F16BP is then split into our 3-carbon compounds, DHAP and glyceraldehyde 3-phosphate. But then this interconversion between DHAP and G3P occurs, mediated by the enzyme triose phosphate isomerase, often abbreviated as TIM, T-I-M. And let's then put in a little bit of stoichiometry here. So ultimately, if we start with 1 glucose, I'll just put ones in front of all these. So 1 ATP going to 1 ATP and so on. What we get then finally is 2 glyceraldehyde 3-phosphates. Okay, once the 6 carbons of fructose 1,6-bisphosphate are split, we get 2 of these G3Ps. So in this next step, glyceraldehyde 3-phosphate is going to be converted to bisphosphoglycerate. So from these 2 glyceraldehyde 3-phosphates then, we're going to take 2 NADHs and convert them to 2 2 NAD pluses and convert them to 2 NADHs. Okay, so that's this conversion here. Next, we will take 2 ADP and convert them to 2 ATP. Then lastly, phosphoenol pyruvate, when it's converted to pyruvate, we'll take 2 ADP and convert it to 2 ATP. And this is another enzyme that we really should mention. This is pyruvate kinase, PK. So the 3 really important enzymes that you should know from glycolysis: hexokinase, phosphofructokinase, and pyruvate kinase. Now obviously all of the enzymes involved in the pathway are important, but these are the 3 regulatory points of glycolysis. If we were to summarize our total net gain here from 1 glucose, we would get then 2 pyruvates. So again, there's a 2 in front of each of these, and there's 2 in front of each of these ADPs and NADHs. So the net gain from 1 glucose, you could either say 1 mole of glucose or 1 molecule of glucose as it proceeds through glycolysis, would be overall a net gain of plus 2 ATP. So notice we lose 2 here. We gain 2 ATP here, so now we're neutral, and then finally we gain plus 2 ATP there. Also, we gain plus 2 cytosolic NADHs. Okay, and that's from this enzyme here, glyceraldehyde 3-phosphate dehydrogenase. And then we also get plus 2 pyruvates. So this shorthand way of sort of laying out glycolysis is something you should be able to do from memory. I think if you can sort of incorporate this in your studying, it will really help. All right, good luck.